different problems, and your assignment will be the problems we do not do together. Let's look at the very first problem. The first problem is asking you to find the sum of the series 7 plus 12 plus 17 plus 22 plus so on and so forth until you get to 52. So the first thing you want to do is try to see, is this geometric or arithmetic? And if you notice, in between 7 and 12, 7 plus 5 is 12. 12 plus 17, or 12 to 17 has a 5. 17 to 22 is also a 5. So we assume the values continue in that same number pattern. And so then this tells us this is arithmetic. And so what we want to do is use that equation that we learned previously to find our value for n. Then we go ahead and do our sum. So in this case, we use the previously learned equation of a sub n equals a sub 1 plus n minus 1 all times d. That's the equation we learned previously. And then we're going to plug in the values we have. We know our final value is 52, so that's our a sub n. Our initial value is 7, that's our a sub 1. We do not know our n, but we do know our d is 5. And those values came from the problem. So then I'm going to go ahead and simplify. We have 52 equals 7 plus 5n minus 5. And if we continue to simplify and watch our signs, we end up with 5n equals 50 and n equals 10. But we're not done. That's what we did previously. In this type of problem, we're looking at finding the sum. And so in order to find the sum, we're going to have to use this equation up here. So what we're going to do is plug an n into that, along with a sub 1 and a sub n, which we already know, to find our sum. And so what we're going to do is we're going to take 10, which is our n, times a sub 1, which was 7, plus a sub n, which was 52, all over 2. And that's our sum. And then we're going to simplify. This becomes 10 times 59 all over 2. 10 times 59 is 590 divided by 2. And our final answer is 295. So in this case, all I have done was I found n by using that same problem we did in the previous sections 11.1 to 11.3, and then plug that in to get to 295. So if we continue on the page, the next problem is identical to that problem, so I'm going to let you solve that one on your own. So is this one, and then we're going to do a geometric one. Let's move ahead to this one. So find the sum of the series 7 plus 14 plus 28 plus 56, and all the way to 7,168. So 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. So that tells us this is a ratio. So this is an example of a geometric problem. So when they're geometric, we do not need to find that n because we already know our r. So when we go ahead and plug that into one of those two equations, we know that 7 is our starting value, so that 7 is our a sub 1. And we have also been told our final value, and the final value that we are being told is 7,168. So we're going to take a sub 1 minus 7,168 multiplied by our ratio, our r, which in this case is a 2, all over 1 minus that ratio, which is 2. And if you're unsure where to find this equation, go back to the top of your paper, and that equation is right here. So once we have plugged in those numbers, we will continue on to find our solution. So when we simplify this, it becomes 7 minus 14,336 all over a negative 1 equals a negative 14,329 all over a negative 1. A negative number divided by a negative number makes it positive, and so our sum is 14,329, and that is a positive value because a negative divided by a negative. Pretty simple. Let's look at the second type of problem, and the second type of problem has that weird E. If you remember back when you took freshman biology, or even if you are taking one of the higher level biologies or Mr. Sweeney's stat course, you have seen this E before, and that E means the sum of. So you might recognize that symbol in math. So this problem is asking you to evaluate the sum of 5 minus 2n for 8 and when n equals 1. So that is giving us a lot of information. And the information it is giving us is that this is definitely an arithmetic. Because if we remember to find the a sub 1, a sub 2, a sub 3 like we did on the last worksheet, we can use those values to go ahead and use the equation we already know. So let's find those out. In this case, a sub 1 is going to be 3, because if I plug in a 1 for n, 5 minus 2 is 3. A sub 2, if I plug in a 2 for n, 5 minus 4 is a positive 1. A sub 3, if I plug in a 3 for n, 5 minus 6 is a negative 1. A sub 4, if I plug in a 4 for n, 5 minus 8 is a negative 3. And if I do a sub 5, 5 plugged in for n, 5 minus 10 is a negative 5. And if I do a sub 8, because it is telling us to go to 8, a sub 8 equals 8 times 2, which is 16. 5 minus 16 is a negative 11. And so that value we get because it is telling us to go to 8. There are 8 numbers in that series. So we're going to plug it into the original equation of a sub n equals a sub 1 plus n minus 1 all times d. Let's go ahead. A sub n, we are being told, is going to be a negative 11 after we just figured that out. A sub 1, we found out to be a positive 3. Plus, we don't know our n, but we do know that we can see our d is a negative 2 after doing that a sub 1, a sub 2, a sub 3, and so on and so forth. So go ahead and simplify. And n equals an 8. Once we get that n, we can then go ahead and put it into our sum. And so now that we know our sum, we can go S equals 8 times 3 plus a negative 11 all over 2. And so when we simplify that, we find out S equals a negative 32. And so those are 2 different types of problems that you're going to see on this worksheet. Now, sometimes it may be a neither. That means if there is no ratio and it's not an arithmetic sequence, all you do is add those values. And so we're going to look at one example of those together. So let's go ahead and move to the next page, and we are going to look at this problem where we have, again, 8 total, n equals 3, and we have negative 1 to the n times 2n. So we're going to go ahead and find our a values. So we're going to start this one with an a sub 3 because it's telling us to begin at 3. So if we plug in a sub 3 equals, so if I put in a 3 for n, I have negative 1 to the third power, which is a negative 1, times 2 times 3. that becomes a negative 6. If I plug in a sub 4, negative 1 to the 4th power is a positive 1. 2 times 4 is 8. A sub 4 equals an 8. A sub 5, plug in a 5 for n, I end up with a negative 10. Let's plug in a sub 6. I have a positive 12. A sub 7, I end up with a negative 14. And a sub 8, when I plug in 8, I end up with a 16. Looking at those values, there is no ratio. There is no arithmetic reasoning for those numbers. So this would be a neither problem. And so all of the ones we're dealing with are finite. And so if I would add these numbers up, negative 6 plus 8 plus a negative 10 plus 12 plus negative 14 plus positive 16, I will end up with a positive 6. And that's all I need to do when there is